Today we're going to explore in a little more detail the slope of a line. On Tuesday morning we started to explore the idea of slope using our iPads, and we mentioned that when we're drawing lines that have a particular steepness or slope, we always use the formula rise over run. So we're going to generalize the ideas that we came to on Tuesday morning, and in doing so, on your own, at home, we're going to be able to explore a little bit more with the iPads next day. So as we go through this lesson, I want you to write down the notes and put them into your duotang so that we can have these as a means to study later on in the semester. So notice here that we're using the variable m to represent the slope of the line. Slope is like the steepness of the line. Today in class, we also said that slope could be described as the rate of change of the line or of a particular situation when two variables are compared. We said that the bigger the value of m, that's what the greater the magnitude means, so the bigger the value of the slope, the steeper the line's going to be. So if we have a line that has a slope of 1, it might look like that. If we draw another line, also going through the origin, that has a slope of 4, notice that it's much, much steeper than the slope of the line that has a slope 1. Similarly, if a line has a slope of 1/2, notice it's not as steep as either the line 1 slope or the line that had slope 4. When we're looking at the slope of the line, we're looking at the line from left to right, just like how we would read English. A bit more of a summary from what we spoke about in class. If a line rises from left to right, we say that it's got a positive slope. If it falls from left to right, then it's got a negative slope. And we explored that a little bit with the iPads today. Copy this down so that we have it as a record in your notes. Let's jot these examples down and get you to try them, and then we'll take them up when you've had a chance to do so. Before we jot them down, let's remind ourselves of what the definition for slope is. Notice again we're using the variable m to represent it. We said the rise was the vertical change or the vertical distance between our 2 points, and the run was the horizontal or left to right distance between the 2 points. So what I would like you to do for the two that we have here is I'd like you to calculate the slope of the lines. Give it a try and we'll check our answers in a moment. Let's look at the first one together. I'm going to start at this point here, and I'm going to figure out how much I'm rising up before I run. So I'm looking here and I rise up 1, 2, 3 units is our rise, and then from that value I run over another 3 units. Using our definition for slope, which is rise over run, the rise is 3, the run is 3. We can simplify that expression, so I would say that the slope of this particular value, the slope of this particular line is 1. Notice that it's a positively sloping line, and our positive value of slope reflects that. Let's take a look at the second one. Let's figure out what the rise is going to be here. So if I'm going to start at my leftmost point, I can say that the rise is 1 unit, but notice that I'm going down 1 unit. So instead of saying that I'm rising in a positive direction, I would say that I'm rising, we may put it in a negative direction because I'm going down. Then I'm running across, and notice I'm going to the right, so I'm still going in a positive direction. I'm going into the positive direction 1, 2, 3, 4, 5. So in this situation, I would say that the slope is rise over run, so it's -1 over +5. Notice that the value of slope that we're getting is a negative value. Hopefully this makes sense and recalls you to when we talked about negatively sloping lines when we worked on the iPads in class. Just a little other note to consider. Let's say I decided to start over my rightmost point instead. If I'm trying to get from right to left this time, I could rise up, and since I'm going up, I'm going 1 unit up, so my rise would be 1 unit. But in order to get to that other point, I'd have to go left instead of right, so my run would be a negative value. So if I wanted to think about it like this, I'd have a 1 rise and a negative run, but notice that I'd still get a negative value for slope once I combine the negative and the positive values. In the first situation that I did in blue, I made the negative go with the rise, or the numerator. So we have a negative divided by a positive, which gives us a negative as the whole value of slope. In the second situation, we put a positive with the rise and a negative with the run, but since it was a positive divided by a negative, we still ended up getting a negative value for slope. Whichever way you want to think about it is really fine. Lots of people like to start with the left and move to the right, but I just want you to be aware that there are other ways to think about it. Choose the method that works best for you. Let's take a moment now and copy down this example and try to finish it together. So let's summarize the information that we have. We know that we have the point -1, 3, and we know that the slope of the line is going to be -5/3. I've chosen to put the negative with the numerator, with the rise, instead of with the run, but keeping in mind what we talked about on the last slide, we could actually write it the other way too. First thing we're going to do, just like we did in class, is to plot the point that we're given, the ordered pair. So that's a value of -1, +3. So starting at the origin, going left 1 unit, up 3 units, there's the value of our point. Or sorry, there's the location of our point, I should say. Now that we have 1 point, we're going to use our values of rise and run, our slope, to find another point that lies on our line. Notice that the slope here, the rise, is -5. So think for a moment, would that imply that I would move up or move down if it's a negative value? Hopefully you'll agree that this means that we'll move down 5 units. So from the point we graphed, 1, 2, 3, 4, 5 units down, and then we're going to have a positive run, so we're going to run 3 units right, 1, 2, 3, and we plot our second point. Notice that we can see our rise is -5, and our run from here to here is +3 units. We have our 2 points. It's hard for me to do this on the iPad, but I'm going to try to use a nice straight line to join our 2 points and to plot our line. So the coordinates of another possible endpoint are this point right here. Notice the coordinates of that particular point will be 2, -2. Here's one last example that we can try together. Take a moment, copy it down, and have a go. The first thing we need to know is what we mean by the road grade. Grade is really the steepness or the slope of the line. In this situation, we say that the road has a grade of 3%. I'd like to change that into a fraction, simply because all of my other definitions for slope have been in fraction forms as rise over run. 3%, hopefully we'll remember that percent means per 100, so I would say that the expression that represented that grade would be 3/100. We've also drawn a little picture here of what the road might look like. Notice we want to find out how far does it have to rise over a run of 600 meters. So I want to label my diagram appropriately. I've got a run of 600 meters, so the run is the horizontal distance. There's 600 meters, and I'm trying to find this rise that we have. So I might let X represent the rise that my road is going to have. So let's plug in what we know. We know that the rise divided by the run, we know that for this situation it's equivalent to 3/100. In our case, we don't know what the rise is. So I've called that X. I know that the run is 600 meters. I've made a direct substitution to work that out. Looking at this, we see that we have some nice ratios here, that in order to make sense of this, and we have a proportion where our two ratios are equivalent to one another, I know that if I wanted to get from the 100 to the 600, I would have to multiply by 6. If I do that to the denominators in my proportion, I need to do the same thing to the numerator, times by 6. So in this case, I know that the rise is going to be equal to 3 times 6, or in other words, 18 meters. There are lots of other ways we can solve this proportion, and we'll talk about other approaches in class when we convene. Take a look at the homework at the bottom. I'll give you a chance to get started on that tonight as you're watching the video. Tomorrow when you come to class, we're going to be using the iPads to delve into slope in a little bit more detail so that you can get some feedback from me and from your classmates regarding whether or not we need a little bit more work here or whether we're already awesome. We're not there, but we will be there, just not yet. So keep working hard, and we'll see you tomorrow. Have a great night. So let's practice finding slope a little bit more using some unique lines. Here are two lines. I'd like you to copy them down and use them with our definition of slope, rise over run, to determine the slope of these two lines. So if we think back, we know that slope is equal to rise over run. Slope equals rise over run, and we have 2 points there that we're identifying and using, this point right here and this point right here. If we're considering the rise of our line segment, notice that I'm not really going up or going down before I start to run across. So I would say here that the rise is 0. The run that we have, there are 1, 2, 3, 4 units between the 2 points. So we'd say that the rise is 0, the run is 4. When we divide those values, we will get 0. Notice that we're getting a value of 0 and it's a horizontal line. Hopefully this makes sense to you. When you're thinking about the steepness of a line segment, if it's completely flat, like a horizontal line is, then clearly the slope will be 0. Take a moment now and try the second one, where we deal with a vertical line. In this case, the rise of the line segment, we notice that to move from one point to the next, we go 1, 2, 3, 4, 5, 6 units up or down, depending on which point you start with, but that there's no run, so we're not moving across to generate another point. So I would say 0 is our denominator here, or our run. If you were to take your calculator and type in 6 divided by 0, you'd find that you get an error. In mathematics, we say that this value, when we're dividing by 0, is undefined. This is something that we're not ever allowed to do. It's a real mathematical no-no. So the slope of a vertical line is undefined. We're going to talk about this in a lot more detail in class, and I'll tell you some other stories about where this undefined expression came into play in different types of engineering and how that impacted things that happened in our world.